All right. Well, welcome everybody. Thanks for taking a little time to talk about service-oriented Lean Six Sigma. You know, the American Society for Quality got founded back in the 1940s, uh, but essentially it was very focused on manufacturing, and it still is. About 80% of its membership is still manufacturing. However, what we know now is that most of America works in services. At least 80% of America works in service industries. And so we have to find a way to tweak what we already know about Lean and Six Sigma and apply that to service things. And it's a different kind of little different approach than you might think. Back in 2017, one author in the Harvard Business Review said Six Sigma is too complex and time consuming to fit into a regular workday. We need tools that don't require entire organizations to go undergo week-long training programs. So this is what I've done over the last 20 years. I call it Agile Lean Six Sigma. And other companies have started to learn this approach, especially service-oriented ones. And the ones that I've worked in healthcare, when they get me, I do a one-day training to get people through Lean and Six Sigma and get results. Now, this takes a little bit of prep, and we'll talk about how to do that. Traditional Lean and Six Sigma training started with a big binder, and you had 2 to 4 weeks of training, which turned people into a green or black belt. And then, supposedly, you started a project, and which could take months or years. I saw one of the consultants at one of the conferences say they'd done a study and that they found that most projects took 4 to 16 months. I thought, who can wait that long? Leadership is not going to wait that long to get results. So what do we have to do? We have to figure out how to tweak what we do in the Lean and Six Sigma world for service industries so that we can get results in a timely fashion. And there are a number of companies that have been doing that, and I'll tell you about those in a minute. So when I think about improvement, and in IT, when I got started in quality improvement, it was because the VP of computer operations brought in Florida Power and Light to train us all in quality improvement, right? Because in those days, originally it was just one little dumb terminal talking to one big box, IBM mainframe or something. But then we got so many systems that this smart dumb terminal became a smart terminal, and it had to talk to 6 or 7 different things to be able to do whatever it was supposed to do. And it had become much more complex than it was in the early days. Now, you have to understand, I started programming in COBOL in 1973 on an IBM 370 158 or something like that. So, back when disk drives were ginormous and only held 250 kilobytes of data. So that was a different time, right? But we had to start to do some improvements. Now, at the time, it was total quality management, PDCA, which became DMAIC in the Six Sigma world. And, it's transitioning. You're seeing more things like operational excellence. You're going to hear a lot of words, but they're all interrelated, and we're going to use a lot of the same tools to achieve this outcome. So when I think about it, there are really complicated problems, of which they are few. There's not a lot of really complicated problems out there. But when you do that, you might need exotic tools like a full-blown DMAIC and design of experiments. They're complex. There's a bunch of simple problems, which can simply be solved with trial and error and just go do it. Because where I sit and I talk to a lot of people about QI macros and what they're doing, I find people trying to use Six Sigma to solve a problem that's so simple that they already know how to fix it. That's a giant waste of time, okay? Because guess what? You don't get any traction or any mileage. And then guess what? Your leadership team shuts down your Six Sigma team. And one of the things about that training that we've had people going through is I hear this phrase often in these conferences, one and done. So somebody gets their Six Sigma training, they do one project, and they never do another project. Well, I think that's a money-losing proposition, right? If people aren't continually making improvements using the tools, guess what? You wasted that. but you added to somebody's resume. But the vast majority of problems wherever I go and the people I've worked with are largely uncomplicated, but you need some data and some key tools, the 7 key tools, and I'll talk about those. And you need a simple method. And I was sort of in between TQM and Six Sigma way back when. And I thought, well, what do you have to do? You have to focus your attention using data, then make an improvement, and then you have to sustain that improvement, honor your progress, and rinse and repeat for your entire career, right? Because everything keeps changing. So this is an approach to get to the vast majority of the problems that exist. Yes, there are more complicated ones, but until you've really done all of these, it makes no sense, right, to try and roll out your more complicated problem. The other thing that I find in this training is that when we teach people complicated tools, they think they have to go find a problem to solve with that complicated tool. So if they have to go find design of experiments, no, right? Let's just use the simple tools and get them all right. Ryan on my team is does tech support, but his father made pool cues and played a lot of pool and won a lot of money. And he said, if you make all the easy shots on the table, very often there are no complicated shots left. And I found this very much to be true, and we'll talk about that. So in the last several years, I've attended a lot of conferences, gone to a lot of presentations, and the service hacks have been rediscovered by a number of companies. Now, some were manufacturing, but very often it's still the same thing. So Christus Health was one of the companies that presented at the Lean Six Sigma conference in Phoenix a few years back, and they had a big Sigma effort, and they'd been training green belts and black belts, and their leadership team was not getting the results. And they said, well, can you find a way to do this in a day and deliver results? Well, you can imagine that the quality team that was trying to do all this freaked out. But what they did was they collapsed it down to a one-day training, and they set it up so that you had to have a team that had a real project with real data to solve, right? If you didn't have a data and you didn't have a problem, then don't bother us. We're not going to train you. And then they would do the training, and then they would go implement the improvements and get results. And so they very quickly discovered that this worked. Now, again, healthcare desperately needs help. According to the latest trends, we have about a $3 trillion spend, and it's estimated that $1 trillion of that, 1 trillion, goes for waste, rework, lost profit, patient harm, and whatever. And that doesn't even measure the cost to the patient and their family if something goes wrong. Just so you know, the Institute for Healthcare Improvement says that 1 out of every 2 patients in a hospital suffers some sort of preventable harm. That's 1 out of every 2, right? Just 1, 2. You just point to the different patients, the different room. 1, 2, right? So this is an area that really can stand some improvement. And next week, I'm actually doing a zero harm $1 trillion prescription webinar for a bunch of these folks. So, I'm trying to move the needle on that. Now, Novartis makes drugs, and Novartis had a problem because they were not getting their drug samples out to their reps to go to doctors so that they could sell their stuff. And they had the same problem that everybody else had with Big Sigma. And so they instituted a 2-day program, 1 day of training, another day of actually applying that training, and they collapsed the cycle time to get new drugs to reps to get to doctors, and so that speeds up their sales process. I also saw another one with Crayola. They had a 2-day program, and Underwriters Laboratories has 14,000 people all over the planet. And so you can imagine it's a little hard to train 14,000 people. You can't bring them all into a room, and especially with COVID, you can't bring all those people into a room. So they developed a 1-day online training, and I have a free 1-day online training, yellow belt training that anybody can take. at lssyb.com. But the idea is that one day training, and then they had a separate day, which was, this is kind of blended learning. So you have online training, and then they had a blended session where live and in person we got together to work on solving a real problem, right? And I just saw a presentation the last week by Lincoln Financial Group, who is doing exactly the same thing, right? So a little bit of training and problem solving, training and problem solving very quickly. So this is where we have gone to. And the great thing about this, if you're going to work in manufacturing, yes, you need to know all that nonsense that we teach in Six Sigma. If you work in a service industry, you do not. So how do we hack Lean and Six Sigma to start getting results for service industries like healthcare or, financial industries or anything like that? Because most of America works in a service industry. And even in manufacturing, most people in the manufacturing thing do not work on the factory floor. A lot of that's automated. It's all the backroom functions like purchasing and payments and invoicing and marketing and sales. All of those things are service related. And even if you think a little bit about IT, guess what? We're in the service business. Yes, we make ones and zeros, but we're in this business where we want to take in requirements, and Agile's got it down. So we build a little, test a little, build a little, test a little, build a little, test a little. That's Lean. Okay, that's where they got that idea. It was from Lean. All right. So this is a thing where I think we can do a much better job. And I've done a number of projects in IT, so I'll tell you about a couple of those. So anyway, the first idea is pre-work. We're going to select a team that has a real problem to solve, and they have data about the problem. Now, I don't know what it is. Everybody has high anxiety about, well, do we have good enough data? Yes, you do. Okay. One of the things I've learned over time is all data is systematically distorted to make someone look good. And so since it's systematically distorted, we can use it to make improvements. This is not complicated. And so once we get the teams together, maybe we get 3 or 4 teams together, we're going to do a one-day training. And we're going to train those teams in key improvement tools and apply them and their data to the problem and figure that out. And then we're going to do the post-work where we actually implement the countermeasures and measure results. I don't know why my drop down always wants to come down and show me things I don't want to know. There we go. So how do we hack Lean? How do we hack Lean? And where do we start? Well, in a service industry, you want to shrink the arrows. And we can use this advanced technology called a Post-it note, right? And Post-it notes, we can diagram the process. They actually make little arrow-shaped Post-it notes. And those arrow-shaped Post-it notes in service industries, that's where 95% of the delay occurs, is in between steps. So you do not need to make people faster at their jobs. In healthcare, you do not need to make clinicians faster, right? Because they're only working on the patient 3 minutes out of every hour and trying to make, if you could cut that time in half, you don't save anything. But if you can shrink the time that the patient is waiting, guess what? That accelerates the process and treatment and all kinds of things like that. So what do we want to do? We want to shrink the arrows. So here's a group of nurses doing a value stream map. And value stream mapping is a lot like, flow charting, but it's just a little higher level. So we have the big Post-it notes and the arrows in between. And once they do that, they figure out how to redesign a nursing unit to speed everything up. And invariably, we collapse the cycle time for doing anything in that nursing unit by 50%. This is not complicated. So it usually takes an hour to diagram using a spaghetti diagram or a value stream map what's going on, and then they redesign it, and then we send them off to go fix the stuff. All right. This is And it's funny because in a very short window, an hour to define and an hour to come up with the revised, and then you go implement it, you collapse the amount of time that nurses spend commuting around to get stuff. Now, the funny thing about that is, guess what? You get happier nurses, you get happier patients, you get better outcomes. It all works out in a positive way. So that's value stream mapping. So super easy to make that happen. Now, if we think about that, in a service industry, a lot of it is delay. All right, so I want you to think about we wanted to reduce delay, defects, and deviation. And this is a key tool. And if you do learn nothing else in here, if you get the delay out, I don't know about you, but we used to have to wait weeks for somebody to do a sign off on something. Well, why did we need that sign off? Well, you know, the VP of whatever was on vacation, so we couldn't get it signed, so we couldn't start work, so we couldn't do something. The arrows are a big problem in IT development as well. All right, so just contemplate that as a thing to really work on. Speed is the healing app. All right, so let's talk a moment about how would we hack Six Sigma to deliver results in a service-oriented industry. Well, first of all, we need some raw data, and raw data about pivot tables that we can then pivot that data and turn that into control charts, which are key to not only analyzing our start, but also to sustaining that improvement. You know, if you don't learn about control charts, you will not be able to sustain the improvement that you are getting. And I talk to so many people. They say, Jay, we made this great improvement, and 6 months later it was gone. And I say, well, did you put in control charts to monitor it? And they go, well, no, we didn't do that. And I say, well, then, you know, if you're not willing to do that, don't start making improvements. Then we'll probably need a Pareto chart, which helps us to narrow our focus and pinpoint what needs to be fixed. And then the big bar of the Pareto chart becomes the head of the fishbone diagram for root cause analysis. And if you do this well, your cause and effect diagram will not be that complicated. The whys will not be that complicated. The answer will sort of leap out at you. And then we come up with an action plan to do countermeasures, and then we measure the before and after with a control chart. We can show a before and after with Pareto charts. And if we have too much variability of stuff, like cycle time to do something or whatever, we can actually show the difference in a histogram before and after. And if we're unwilling to show the before and the after, guess what? We're not really doing the kind of job we should be doing. So I want you to get this idea that most of the data you will see is overcooked. It's been over-summarized. And so here's some example of deaths over some sort of graft surgery for hearts. But it's so summarized by quarter that we cannot begin to tell anything about the people that died. So until we know exactly what happened with the people that died, how old were they, what was their condition, how were they treated, what stent was used, I mean, all of these dang things, all right? Those are the things we can't tell anything about. And so we need that data to figure this out. So I'm going to encourage all of you to go on a raw data diet and use your pivot tables to make this work. So at the minimum, what do you need? Well, you need to know when something happened, when the error happened, where it happened, and what happened. Now, if you think about a trouble log in IT, the thing that you almost always invariably find is that a few modules are error prone. And that's where all the errors show up. And everything else is fine. And then there might be another module or two that needs a lot of enhancements, right? And so what we want to do is come back in and go, oh, the enhancement prone one, maybe there's a way we can take the hard-coded stuff in there and pull that out into a data table so that we just look at the table, but we don't have to change the code. The same thing is true on the other side, which is the error prone, right? Maybe that one needs to be rewritten or really analyzed to find out why it's screwed up. I remember back when I was early on, I was working on a system 5 crossbar that was written by some folks at Bell Laboratories, and one guy had written a module, and just to be funny, he made all of the paragraph names women's names, first names that started with the letter A. So it was, go to Abigail, perform Amy until. It was like, come on, dude. Well, that was right. So we find it very hard to maintain that. So think about, you could do this with trouble logs, right, for a system and pinpoint the one or two things that are really problematic all the time, fix that. And the one or two things that are really enhancement prone all the time, and figure out how to make them more enhanceable and easier, right? So I can do that on the fly just by changing data. So I know you know this, but I'm just reminding you that this is the sort of thing we can do with these tools. So we need to know the when, the where, and the what, but if we know how much it's costing, who's it's affecting, and why is it going on, that will help as well. So if you have data that looks like this, so this is a region by hospital, by admit date, denied insurance claims, right? So here we do, right? Where did it happen? What hospital? When did it happen? What are some of the issues here, like function codes and so on? And how much did it cost? Well, guess what? You start adding up all those numbers, and that's a lot of money. That was worth $5 million a year. Now, back then, it took me quite a while to actually do the analysis and do all the pivot tables and draw the charts and figure out what was going on. But it only took about 2 hours for the team that came together to do root cause analysis to figure out what to fix. They went in, they left on a Friday, implemented the changes on a Monday, and saved $5 million a year. Now, if you have data that looks like this, and this is still a little bit more summarized because I couldn't find the original data, but this is about the telephone company. So they were having orders going through the cell phone group, and they were having things that affected customers, affected their service, affected billing, affected all kinds of stuff. And so what we had to do was go in there and do some analysis and winnow this down and figure out, okay, why is this going on? Again, this is an IT-related system, right? But the problem was they had so many errors that they had to hire temp workers to come in and fix them. And so they were spending like $250,000 a month on temporary workers to fix this stuff so that they didn't get really in trouble with customers. Now, the problem was if we didn't fix some of these things, guess what? That customer would call us. And every call cost $9 to $12, right? And so it's just, ouch, right? Ouch. So the when, the where, and the what. But that was worth $3 million a year. Again, it took me a while to do the analysis. Then we had to get the right people together, and we had to work our way through each one of these types of errors. But in a very short period of time, we were able to figure it out. Now, it did take about 3 months to weave this into the release system so that we could make those changes and get them out there. So it took about 3 months to actually get all the changes made. And then, guess what? Problems collapsed, right? 4 of the top 5 errors vanished, and the other 2 were cut in half. That's a big improvement. We went from a 17% error rate to a 3% error rate, like overnight. And it was so funny. I remember the systems analyst called me up when he implemented this thing. And he said, "Jay, you won't believe it." I said, "What?" He said, "You won't believe it." I said, "What?" And he said, "Well, we eliminated the top 4 errors and cut the others in half, and dramatically reduced all these problems. And now we can finally let all these temp workers go, right, and get back to doing a normal business." I said, "Well, good." And then the following year, they cut that 3% down to less than 1% error. So this is the kind of thing we can do with the Six Sigma in an IT organization. So what we need is a little data mining wizardry. We're going to take this raw data, right, about hospitals and denied charges, use pivot tables to summarize them. Now, when you start with raw data, you can go back to exactly each individual thing and figure out what went wrong. If it's already summarized, you have no idea what went on. So from here, we can get all the way back to pivot tables, count and categorize, and then turn those into control charts, Pareto charts, and fishbone diagrams. So let me show you an example. So again, this is the hospital study. And it turned out that I got like 47,000 records for part of a year of denied insurance claims and different claims. But they were losing over $1 million a month in denied insurance claims. Well, that's a lot of money. If you had a lot of money, guess what? You could use that to do other things that are more important to serve patients. And so I want you to think about, I always talk about the Paretos Rule, but I call it the 450 rule. So 20% is causing 80% of the problem, but this power law exists within that 20%. So 4% of what you're doing is producing over half the mistakes, errors, waste, rework, lost profit. 4 modules out of 100 are producing over half the pain and suffering and maintenance, all right? So what do you want to do? You want to go pinpoint what those are and then invest some time and energy to make them error-proof and enhancement easy, right? So this is where we want to go. And I call that one step out of 25 the $1 million misstep. This is where most of the waste, rework, lost profit occurs. And this happens in service industries, right? And so this can all be figured out using a little bit of data. Now, I'll give you one example out of healthcare. One of the things they track is patient falls. And one nurse said, "Oh yeah, we figured this out." It turns out that most of the patient falls are men between the ages of 20 and 40 in the orthopedic recovery room unit. Well, that makes sense. They went in for orthopedic surgery. They came out into the recovery unit, and then they just thought they could jump up and run around, and they fell, right? And so do you think they could figure out how to control 20 and 40-year-olds in that facility? Yes, you can. There's a little pad they put under the bed that can tell if you get off of it. I know because I had that experience back in 2014 when I had pneumonia. All right, so they don't want you falling because if you fall, you can injure yourself, and that injury can lead to other complications. But this is the kind of thing you can do with data is narrow your focus down. We didn't need to fix all of the patient falls. We just needed to fix one unit. All right, so we're going to use Pareto charts to find and fix what's wrong. So a Pareto chart is a sorted bar chart with a cumulative line graph. So here you can see timely filing was almost $8 million and was 61% of the total. So this is the 80-20 level, all right? So we can look at that and go, yeah, let's focus on that. Do not focus on everything else. You know, groups always want to end up trying to boil the ocean and fix everything all at once, and they fail because they've expanded their scope. You've had the experience of expanding your scope on your software project, right? And what do? You end up adding more functionality, and eventually you can't deliver anything. Not good. You're better off to deliver something that works than a whole bunch of stuff that doesn't. Now, what we can do is drill down into that timely filing category. And what we found there was one insurance carrier, one. Out of all the other insurance carriers was 64% of the denials for timely filing. One unit. And again, think about the 450 rule. Actually, 64% is about exactly what the 450 rule is talking about. And so what we did was we got people together. They figured out what was going wrong. They figured out a manual workaround, and then they went back to the insurance company and said, "Hey, what are you doing here?" Right? And so, but they left on a Friday, implemented on a Monday, and they were able to reduce denials dramatically. So here you can see a before control chart and the after control chart, right? And much lower variation. It was almost $400,000 a month. And they went on to improve even more. They had $24 million in rejected claims, and we figured out how to fix that as well. Now, rejected ones, you don't lose money, but they get delayed. And you don't want to have your paycheck come in late. So that's what a world-class improvement looks like. Now, let me show you just for a second. So this is what the data might look like, right? So by date, by nursing unit, patient harm. This is what the denied insurance claim data look like. There's in manufacturing, you could have something like lost time caused by generator failures or whatever. Manufacturing, folded flap defects. But in essence, if you have these things, and in every healthcare system, they have medical record systems, and you can dump the types of harm out of that medical record system, then you have something to work with. And in any organization, everybody's collecting data, but nobody's using it. Okay, I always call this where the invisible low-hanging fruit lives, is in this kind of data. Anyway, so in the QI macros, a couple of years back, I built a improvement project wizard. So I select two headings up here and click on the improvement project wizard. It'll go bash through there and pivot the data and create control charts and Pareto charts and fishbone diagrams and look for what are the projects in here. So it got a control chart and it came up with two improvement projects. It has a high level 80-20 rule Pareto and a lower level 450 rule Pareto and a fishbone diagram. And even if you have decent information, it'll invent the story behind this. All right, so here's our control chart. So we can see we're getting about 8.5 patient problems. And again, the wizard did most of this. And then we want to come over here to the next level. So this is our 80-20. And here you can see unit 3 is 53 some odd percent of the total. And then if we drill down into that, we can see in unit 3, patient falls are 39% of the total. And everything else is sort of secondary, so we want to fix that one first. So again, we're narrowing our focus. And then I'll build a fishbone diagram that says during 2020, patient falls accounted for 40% of unit 3 patient harm. And let me clarify something for you here. At this point, you know exactly who should be on your team. Before that, you have no idea who should be on your team. Until you do the data analysis, you have no idea. There's no sense gathering people together and trying to brainstorm ideas. That just doesn't work, right? But if you let the data lead you, you will be able to solve real problems. And so at this point, we know it's people in Unit 3 who know something about patient falls. Now, it doesn't stop there. It keeps looking. So we look at by type of harm. There's patient fall, medication error, pressure injury. So all three of these are 2/3 of the total error. What could we do here? We could actually start teams in each area, but we want to drill down a little more. So if I drill down into patient falls, Unit 3 is 80% of all patient falls. Guess what? We got to fix patient, Unit 3. Again, this is that idea of 20 to 40-year-olds in the orthopedic surgery recovery unit are the people we have to fix. And we come up with another fishbone diagram. So we have two different ways of looking at this problem, and then we can get to going on actually solving that problem. All right, so that's kind of the structure, what can be done, right? And this is a form of programmatic AI where I built my mental strategy into the software to make that happen. How can you build things into your software that automate things that people are not that good at doing repeatedly, and so that you can just make them look smarter? So anyway, that's the idea behind this, right? Control charts, Pareto charts, cause-effect diagrams, then measure the improvement at the end. And we want to hack Lean and Six Sigma training. The training we do covers a lot of ground that isn't needed to be covered. Years ago, I spent 5 days in a control chart class, and I spent 4.5 days learning how to calculate these formulas on a handheld calculator. Waste of time, all right? There's software to do that, mine or somebody else's, right? And so I took and actually built the control chart decision tree into the QI macros so that you can actually just select data, click a button, get a chart. Let me show you that just for a second to give you some idea. Start thinking about ways to automate things. So if you select the data with your mouse, we have a control chart wizard that'll look at that data and say, well, that must be what's called an X moving range chart. And it'll show any out of control conditions and trends and things of that nature. And I actually built in a process change wizard to help people show when the process actually changes. So think about, how do we start to automate things that people have trouble learning and doing correctly? And so why do we need to pivot now? Well, I think we need to avoid extinction. Because the vast majority of the world works in service industries. So we don't have to teach them everything they need to know to work in manufacturing. And most of the manufacturing is now done overseas. So only like 8% of America actually works in manufacturing. Still a big industry, but that's not where the big money will be. And so this is kind of an agile approach. So it's small, agile teams, accelerating speed and adaptability, using data to laser focus project, get people engaged, and get things done. So you can be here, right? Start collecting data, analyzing it, improving it, and let's get to hassle-free quality, a hassle-free America. This is what I call a money belt, somebody who can use the tools of quality to save money. I don't care what color your belt is. If you can't save money, you will not be employed for very long. So we actually have a yellow belt training online. The other nice thing about doing this one-day approach is, out of that 20-odd people that come in, maybe 3 or 4 teams, stunningly, 1 or 2 people really stand out as being enamored of quality improvement. And so you can send them on to green or black belt training because they have an aptitude, a desire, and really could benefit from that. We're not just training people at random. And I think you see how people are using Agile to make this happen, and our 7 key tools for Lean Six Sigma success. So anyway, I'm Jay Arthur, and that's a little bit about what to do here, and you can reach out to me if you want to. If you go out to our website, you can go to qimacros.com/agile, and you'll actually find a link on there to download my free Agile Lean Six Sigma book. And you can also take my free LSS Lean Six Sigma Yellow Belt training online.
Jay, thank you so much for joining us today.
Thank you.